Hey guys, welcome to ANS Solver. Today we'll be learning the concept of iterative functions and convergence, which is a subtopic in the chapter of numerical solutions. So we'll be learning this concept via past paper examples. Okay, so this example is basically from 2020 October-November paper 31. Okay, so the sequence of values given by the iterative formula x with n plus 1 is equal to pi minus sine inverse of 1 over e raised to minus half xn plus 1. So they have given us an initial value here which converges to one of these roots. Okay, so if this is the first time you're learning this concept, you might not understand this, okay, by what I just said, correct? But this is really simple. Okay, so basically, as you know, they have given you an initial value here which is x1. That means I need to calculate x2, x3, x4, correct? Like that. That means if the next value I need is an x2, how will I get an x2 here? If my n, okay, is equal to 1, correct? So basically, what I do is I take my n which is equal to 1 only because an initial value is given to me, correct? Sometimes in some questions they don't give you that initial value, so you need to start from x1 itself. So you take your n as 0, but in this case you have your x1 value, correct? So now what you basically need to do is you can write this as x1 plus 1, which is x2, which is equal to pi minus sine inverse of 1 divided by e raised to minus half into x with x1, because n is equal to 1, plus 1, correct? This is what I basically get. So now I can write this as x2, which is equal to pi minus sine inverse of 1 over e raised to minus half, correct? Now this will be multiplied to the x1 value, which we have here as 2. So I write 2 here plus 1. So now what I can simply do is I can solve this on the calci. So when I do that, I get my answer as 2.3217, which is to 4 decimal places as they have asked us, and the final answer should be to 2 decimal places. So this is not the final answer. Now what you need to do is you need to calculate x3. Now for x3 you need to listen to me carefully. Wherever you have put 2, correct? This is the value of 2 in the bracket. Remove the 2 and click on the answer button. Basically it will look something like pi minus sine inverse of 1 divided by e raised to minus half into the answer button plus 1. Make sure you're in the radian mode, correct? Now when you just click on equal to after inputting this, you get your x3 value as 2.2760. Now for x4 you just need to click on equal to. Just need to click on equal to, correct? That's the only thing you need to do. So you get 2.2824. Now for x5 you need to click on equal to again. So you get 2.2815. x6 also you click on equal to, correct? So you get 2.2816. x7 also you get as 2.2816. and x8 when you again click on equal to, correct, you get it as 2.2816. As you can see from the last 3 times, the value of 2.2816 has been recurring, correct? So how many ever times you click on equal to, you won't get a different answer. So 2.2816 is your final answer, which you need to write to 2 decimal places as 2.28, which is basically your final answer. Understood the method? This is basically the method. Here The only difference in some questions is here you took your n as 1. Sometimes they don't give your initial value. So in that case, you need to take your n as 0. Correct? In that case, you need to take your n as 0. This is important to remember. Correct? Here, because the value is given, you take your n as 1. Now, let's do another example. This is from 9709, 2020, October-November paper 21. The sequence of values is given by this the iterative formula, and the initial value is given as x1 equals to 2, which converges to alpha. Now we need to use the iterative formula to find the value of alpha to 4 significant figures, give the result of each iteration to 6 significant figures. Okay, so you can write this as, because you have your x1, you already have your initial value, so you take your n as 1. So I can write this as x2, which is equal to 6 plus 8 into x1 divided by 8 plus x1 the whole square. Now you can write this as x2 equals to 6 plus 8 into 2 divided by 8 plus 2 the whole square. Now when you solve this on the calci, correct, you get your answer as 1.83333 to 6 significant figures. Now for x3, you know it's quite simple. Wherever you see the bracket of 2, correct, which is here and here, you simply click on the answer button of the calci. So when you do that, correct, and you click on equal to, you get 1.81907. Then x4 you get as, you just click on equal to get 1.81736. x5 as 1.81715. x6 as 1.81712. x7 as 1.81712, and x8 as, just one second, yeah, this is x8 as 1.81712. Correct? So as you can see from the last 3 iterations, this has been recurring. Correct? That means how many ever times you click on equal to, you won't get a different answer. So your final answer to 4 significant figures is 1.817. Correct? This is what you need. Now another point to note here is that you don't need to show all these iterations. Okay, because in the mark scheme also they always say at least one iteration needs to be shown. What you can do is you can minimum show till x3, correct? Then you can just keep on spamming equal to and get the recurring answer. Correct? Because you don't need to show everything. It's okay also if you show everything, there's no problem. But it's even fine if you skip some iterations. It's perfectly alright. So minimum show just 4 to 5 iterations with the recurring thing. Correct? So that should be sufficient to get your marks. Correct? And another point to remember, because you had the initial value, you took your n as 1. If the initial value is not given, then you take your n as 0. I'll just write it here for your reference. If the initial value, okay, is not given, then take your n equals to 0, because then it will start from x1. Here it's starting from x2, but if no initial value is given, then it has to start with x1. Correct? This is the thing which you need to know. Now, normally with that iteration, they ask another type of question sometimes. They'll ask you state an equation satisfied by alpha and hence determine the value of alpha. Very simple to do this. It's basic steps. So the first step is write the equation here without the n plus 1 and n. So you can write this as x equals to 6 plus 8x, correct, divided by, here you can write this as 8 plus x square, because you are simply avoiding the n's and n plus 1. Now what you need to do is you need to solve this, okay, and get a value. Basically you can write this as x into, try to solve this equation, try to calculate the value of x, because x and alpha are the same here, correct? That's what we know because it converges to alpha. So what you can do is you can write this as x into 8 plus x square, which is equal to 6 plus 8x. Then you can write this as 8x plus x cube, which is equal to 6 plus 8x. As you know, 8x can be cancelled on both sides because 8x minus 8x is 0. So you get x cube equals to 6. So you get your x basically as the cube root of 6. So you can simply say alpha converges to the cube root of 6 because it's the exact value, correct? You can't basically give it to decimals, correct? This is the thing which you need to know, correct? Because it's the exact value. So this is basically the final answer. So very simple. First write the equation without the n's and n plus 1 and then simply solve to get an exact value, correct? Now let's do one last type of question. This is another type of question which we normally ask. So this is from 2020 May June paper 33. Okay, so what they'll do is in part 1 they'll give you an equation something like this, correct? And part B, they'll ask you, show that if a sequence of values given by the iterative formula, okay, which is given here, it converges to the root of the equation in part A. So basically what you need to do is, it's similar. What you need to do is write this equation without the n's and n plus 1. So write this as x equals to 4x raised to 5 plus 2 divided by 5x raised to 4 minus 1. Now you need to solve it in such a way to show that you get this equation at the end. Basically in the previous example, you needed to solve this to get a value. In this case, you need to show that you get an equation. It depends whether you need an equation or value. In this case, you need the equation. So you can solve this and write this as x into 5x raised to 4 minus 1, which is equal to 4x raised to 5 plus 2. Now I can write this as 5x raised to 5 minus x, which is equal to 4x raised to 5 plus 2. So this can basically be written as 5x raised to 5 minus 4x raised to 5, which is equal to x plus 2, which can be written as x raised to 5 equals to x plus 2, which is what? Or you can write this as x raised to 5, which is equal to 2 plus x. Same thing. So this is what we needed to prove, correct? So these are basically some of the type of questions which I ask in this chapter. It's a really simple chapter, not much to understand, correct? It's basic procedure and concept. Okay, so with this we come to the end of the chapter. I hope you enjoyed the chapter and learned a lot. Now you can move on to the topic wise questions and solve many different type of questions like the ask and past papers. Even if you get stuck, correct, you have a video solutions, okay, which we provide for every past paper question, so you can refer to that and master this chapter. So thank you very much for watching.